Section 3.2, imaginary numbers. Imaginary numbers, what they're used for are to help us find square roots of negative numbers. Because if you remember in Section 1, we talked about examples where if we had something like x squared equals negative 10. Well, there wouldn't be a way to solve that. There's no real answer because we can't take the square root of a negative number and get a real number in return. Okay, so what they did, and this was a long time ago, was they came up with the imaginary unit, and they called it imaginary because they couldn't quite wrap their head around it. The name stuck, but it's widely accepted in mathematics that the imaginary unit exists. Okay, the imaginary unit is the letter I, and what it's equal to is the square root of negative 1. Okay, so it's not negative 1, it's the square root of negative 1. As a side note, and we'll come back to this a little later, I squared is just equal to negative 1. Okay, keep that in mind. We'll come back and revisit that in a little bit at the end of the lesson. We'll make that a little bit of a parenthesis. Okay, so I squared negative 1, I is equal to the square root of negative 1. So, how we're going to use this. So, for the first examples here, find the square root of the number. We're going to simplify these square roots, but they have negatives underneath. And I'm going to show you how we go about doing that. So, anytime you see a negative underneath the square root, what I would do is I would automatically break this into negative 1 times 25. Just break it, just take away the negative, and we'll go from there. Okay? So, the square root of negative 1, so we can use our product property to split this up. I'm not going to do this for every problem where I've split it up into two separate square roots, but mathematically that's what's happening. We can split this up into two separate square roots. The square root of negative 1 times the square root of 25. The square root of negative 1 is I. That's what it says right here. Okay, right there. And then the square root of 25 is 5. Now, if we were solving, we would need plus or minus, but we're not solving, we're just simplifying, so we don't need plus or minus. And then I times 5, usually if you take a variable times a number, the number comes first. So 5i would be your answer there for number 1. Number 2, the square root of negative 72. Again, split this up right away. So negative 1. Now I'm going to think about 72. 72 is not in the list of perfect squares, but it's divisible by actually a couple of perfect squares. The biggest one that it's divisible by is 36. And 36 times 2 would give me 72. Okay, so I've got negative 1 times 36 times 2, and that'll give me negative 72. Now let's break this up. I'm going to start with 36, just because I know that my number has to come first. Okay, so square root of 36 is 6. Square root of negative 1, that's what I'm going to do next. That's I. Okay, and then square root of 2. I don't know the square root of 2, so I leave it underneath the square root symbol. So 6i times the square root of 2 would be your answer there for number 2. Okay, number 3. Negative 5 times the square root of negative 9. So the negative 5 is already on the outside. So I'm going to make this negative 1 times 9. And we'll go from there. So start with your number. So I still have the negative 5 out front. Square root of 9 is 3. Square root of negative 1 is I. So now I don't have any square roots, and I'm just multiplying this all together. The only two things I can multiply together are the negative 5 and the positive 3. So negative 5 times 3 is negative 15, and then an I on the end. So negative 15i would be your answer for number 3. So the imaginary unit makes up what's part of what's called a complex number. Complex number has the form a plus bi, where a and b are both real numbers. So it's going to be numbers that you've seen before, numbers that you've known for nearly your entire life. Okay, so a and b are both real numbers. Something like 7 plus 2i would be an example of a complex number. Okay, we can use the normal operations, add, subtract, multiply, and divide, with complex numbers. In this video, we're just going to focus on add, subtract, and multiply. Dividing is a little tough, and we'll get to it in a later section. Okay, so let's start with adding and subtracting real numbers. And this shouldn't say real numbers. This should actually say complex numbers. Little typo when I made this slide. Adding and subtracting complex numbers. Really, it's just like combining like terms. And when I say like terms, I mean like in number 1, the 8 and 5 would be combined, and the negative I and 4i would be combined. Okay, so we just got to keep our signs organized. So 8 plus 5 would be 13, and we've got negative I plus 4i. Negative 1 plus 4 is positive 3. So 13 plus 3i, that's your final answer right there. We've added the two numbers together. Sorry about that noise in the background. That was Mr. Thomas making an announcement. So number 2, let's go on. Again, like terms, 7 and 13, and negative 6i and negative 6i. So let's think about this. 7 minus 13 is negative 6, and then negative 6i minus negative 6i, so that's negative 6 minus negative 6. That's actually 0, so the i's actually cancel out. So your answer for number 2 is just negative 6. Let's move on to number 3. So we got 13 minus 2 plus 7i. So we got 13 minus 2, that is 11. Now I have 0i in the first complex number, so I got 0 minus 7, so it's 0i minus 7i, which would be negative 7i. So 11 minus 7i would be your answer for number 3. Hopefully adding, subtracting isn't that difficult. It's just like combining like terms. That's stuff from Algebra 1 and even pre-algebra. We've been doing that for quite a while, so hopefully that isn't anything new to you. Multiplying, though, that might be a little different. We still have to think the FOIL method. Okay, and we have to remember, and this is, remember at the beginning of the video I said I squared was equal to negative 1. This is where that will come into play. Okay, so remember I squared is negative 1. And when we're done, there should be no I squared in your final answer. And I'll show you how that all works out here in just a second. Okay, so let's try a few. Number 1, multiply 4i times negative 6 minus I. Or no, sorry, negative 6 plus I. So we're going to take, this is not going to be FOIL. This is just distributive property because we don't have something that looks like this one down here, number 2. We'll come to number 2 in just a second. All right, so 4i times negative 6 is going to give me negative 24i. And negative 4i times I is going to give me positive 4i squared. Now, remember what I just said. I squared is equal to negative 1, and we don't want any I squareds in our final answer. So this I squared, we can rewrite that as 24i plus 4 times negative 1. Because remember, I squared is negative 1. So this we can think of as 4 times negative 1, which is going to be just negative 4. So our answer here is going to be negative 24i minus 4. Or if you want to rewrite it so that the real number comes first, you can certainly do that, negative 4 minus 24i. Either one of these two would be correct for number 1. Okay? Let's try number 2. 9 minus 2i times negative 4 plus 7i. Okay, we're going to start by foiling. 9 times negative 4 is negative 36. That was the first. The outers, 9 times 7i is, let's see, 9 times 7 is 63. So 63i. And then we'll keep going. Inners, negative 2i times negative 4 is positive 8i. And our last term, negative 2i times 7i, negative times positive is a negative. 2 times 7 is 14. And I times I is I squared. Okay, so we have some terms that we can combine. We can combine these 63i and 8i. We can also rewrite I squared as negative 1. So we'll have negative 36. Let's see, 63 plus 8 is 71. So 71i minus 14 times negative 1. And then negative 14 times negative 1 is positive 14. So I'm just going to write 14 off to the side and cross that off, make it plus. So then the last thing we can combine, negative 36 plus 14, that is going to be, let me find one more color here, we'll do it in brown. We'll have, negative 36 plus 14 is negative 22, and then plus 71i. That would be your answer for number 2. Okay, number 3, so negative 3i times 10i. This is really, there's no foiling, there's no distributing, we're just going to be multiplying straight across. Multiply what you can multiply together, and then if you need to write an exponent, you can certainly do that. So what we can multiply together out of this is negative 3 times 10, which is negative 30. And then we can do I times I, which is I squared. And then we can clean things up. I squared, again, is negative 1, so we'll have negative 30 times negative 1, which is positive 30. So we only have one number for an answer there for number 3. All right, let's try the last one here. 3 plus 5i times 5 minus I. Okay, so this is a FOIL. So 3 times 5 is 15. That's your first. Your outers, 3 times negative I is negative 3i. Your inners, I times 5 is 5i. Put a green dot there. And then the last terms, I times negative I, positive times negative is a negative. I times I excuse me, is I squared. Okay, again, let's simplify what we can. We can do the negative 3i plus 5i. So we'll have 15. Negative 3i plus 5i is positive 2i. And then we'll have, let me go back to purple, minus, and then back to orange, I squared is negative 1. So remember, if it's minus negative, that's the same thing as adding the positive. And then you can combine the 15 plus 1 to make 16 plus 2i. Now, what some people think they want to do is, figure out what they're both divisible by and do that. This is your final answer right here, 16 plus 2i. There's nothing else to do with that answer other than, box it in or circle it or something. That is your final answer, 16 plus 2i. All right, let's move on. So we can also solve with complex numbers. Okay, so these are a couple of examples here that you would have had in homework for section 3.1 that your answer would have been no real solution. Well, now that we've kind of introduced complex numbers and imaginary numbers, we can have solutions. They just will not be real. So technically it's still no real solution, but that doesn't mean it doesn't have a solution at all. It means that there is now an imaginary solution. So for number 1 here, the rules are going to be exactly the same. We want to get x squared by itself. We're going to do that by subtracting 4 from each side. So that gives me x squared is equal to negative 4. Okay, now this would be where a no real solution would come in, but we know that it's going to have a solution. Every problem has a solution, but it just might not be a real solution. So to undo x squared, to undo the square, we want to square root both sides. Okay, so that leaves me with x on the left-hand side. When we're solving with square roots, we always need plus or minus, and then we need to simplify this square root of negative 4. Okay, if we forget the negative for a minute, the square root of 4 is 2. And then to deal with the negative, we have the square root of negative 1, which is I. So our answer here is plus or minus 2i. Okay, we can rewrite the square root of negative 4 as the square root of negative 1 times 4, negative 1 times 4, and that's how we get to plus or minus 2i. Okay, let's try another one here. Number 2, 2x squared minus 11 is equal to negative 47. Again, we want to get x squared by itself, so we'll add 11 to both sides. So that gives me 2x squared is equal to, let's see, negative 47 plus 11. That would be negative 36. And then we'd have to get rid of the 2 by dividing both sides by 2. So that means x squared is equal to negative 18. And then we can go from there. We need to square root both sides. 18 is not a perfect square. So I'll have x equals plus or minus. Let me switch to orange real quick. So negative 18, that would be, let's see, 18 is divisible by 9, which is a perfect square. So we'd have negative 1 times 9 times 2. Sorry, I'm running out of space here. So the square root of 9 is 3. Square root of negative 1 is I. And we don't know the square root of 2, so we leave it as the square root of 2. So plus or minus 3i square root of 2 is going to be your answer there for number 2. All right, the last 2 examples. I forgot to write one, but we'll go from there. Oh, no, I didn't write it. There it is at the bottom. All right, find the zeros of each function. What this basically means is we need to turn f of x into the number 0 and then solve 4x squared plus 20. So when it says find the zeros, basically it means find the solutions. Set it equal to 0 and solve it. So it's really going to be no different than these 2 examples up here. It's worded a little differently and originally notated slightly different, but the rules and the process is going to be exactly the same. Okay, so we want to get x squared by itself, so we're going to do that by subtracting 20 on both sides. So negative 20 is equal to 4x squared. Get rid of the 4 by dividing. Negative 20 divided by 4 is negative 5 is equal to x squared. And then we need to get rid of the square by square rooting. 5 is not a good number. It's not divisible by a perfect square. It's not a perfect square itself. So what this actually means is that x is equal to, and we're solving with square roots, so we need plus or minus. The only thing we can take out of negative 5 is the negative. And the square root of negative 1 is I, and then we still have the square root of 5. So plus or minus I square root of 5 is your answer there for number 1. Number 2, same idea. We want to set it equal to 0. Replace g of x or f of x or whatever letter of x. Replace it with 0. 9x squared plus 1. And go ahead and solve it again. First step would be to get rid of the 1. So 0 minus 1 is negative 1. is equal to 9x squared. Get rid of the 9 by dividing. Negative 1 divided by 9, I'm going to leave it as negative 1/9 is equal to x squared. And then I need to get rid of the square by square rooting both sides. So when we square root x squared, we are left with x equals, and we're solving, so we need plus or minus the square root of 1/9. Now, we don't want any fractions underneath the square root, so let me switch to purple here. So we'll have plus or minus the square root of 1 over the square root of 9. This is actually going to work out very well. The square root of 1 is 1, square root of 9 is 3, and then we need plus or minus, so we have plus or minus 1/3. But I forgot something. I forgot the negative, so the negative should be in there, which means the negative's under there, and the square root of negative 1, which is not just 1, it is 1i. So you can write it as plus or minus I over 3, or you can write this as plus or minus 1/3 I. Either one is correct. So I'll just write either I over 3 or 1/3 I. Either one is fine. It's really neither one. They are both the same, so it doesn't really matter.